I don't know if I recorded. All right, so on the doubling coin part 2, it confirms that we were correct. Oh my gosh, what does it say? Oh, it's correct. It would take about 20 days for you to have $1 million in coin value, right? All right, so it says, how could we determine the number of days before doubling coin has a value equal to any amount we choose, okay? So we're going to work through the problems to come up with how can we determine how many days it'll take without having to do the log every single time, right? So essentially, instead of us giving you the time, we're now giving you the value. And instead of having to solve for log every single time or use log every single time, is there a rule or pattern that I can follow, okay? So first, it starts off here. It says, if you were offered a single payment of $1,000 or a coin that was to double, how long would it take you, right? So just like we saw for $1 million, we would have 2 to the x equals 1,000, right? Agree? I put too many thingies. Because that's what it says.
Oh.
Doesn't it say 1,000? Okay. So 2 to the x, 1,000. What do you notice we would do here? What do you think? Looking at how we solve 3, what should we do? There you go. So if I wanted to do this, I'm like, okay, well, based on how I saw the previous part, I'm going to do log base 2 of 1,000 to get my approximate value. Does that make sense? Because the purpose of doing something is to recognize a pattern. That's all math is a bunch of patterns that were recognized. So with log base 2 of 1,000, what do we get? So we get approximately 9.96 days, which is approximately 10 days. Close enough. Okay, so to do it, we're going to press alpha window 5. Okay, so you can do it that way, where you're going to put 2, 1,000. The other option is you can write it as 2 separate logs. So you can have a log of 1,000. The key thing is to make sure you close your parenthesis before you divide, and log of 2. Okay, either one is going to get you there, right? Well, we're about to get out of school in 15 minutes. She can't do anything. Okay. All right, so either one's going to work. At your table, I would like for you to take a moment to do 2 and 3, and then we're going to check on your answer. Okay, you're going to do 2 and 3 at your tables. Notice that our payments are 50,000 and 125,000. Check with your peers. So for this one, it says that it wants to know how many days would it take for us to have 50,000. So 2 to the x equals 50,000. And how do I solve that? There we go. Log base 2, 50,000. And what did y'all get? So we end up with 16.15? Yeah, 15.6, which makes it 16 days. Okay. All right, and then here we had 2 to the x equals 125,000. And that's going to lead us to log base 2 of, and that gives us approximately 16.9, which means that it needed how many days? 17 days. Okay. Exponential growth is no joke. So with exponential growth, if you put in 2 to the 16, you would see how you have to have 2 to the 17th, right? Because there's going to be a big gap between the 16th and the 17th, okay? Remember, you're doubling that every year. All right, it says, so how would you use a graph to solve this? So if we were looking at a graph, what would we do? If I had a graph with everything out, notice here they're giving us our output, right? So if they're giving us our output, we're looking for the input. So instead of starting on the x-axis, we would have to start on the y-axis and then find our x-axis. That's how you would use a graph. So if we were to graph this or use a graph, we start with the y. With the y. because y is our moolah, our money, right? And then we're going to find the x. So if you flip back over and let's say I wanted, I don't know, $8 or $8 right now. Let's say I wanted $10. Well, this, my x-axis, that represents my days. My y-axis, what did that represent? That represented my value. So I'm going to go 2, 4, 6, 8, 10. So here's 10 and I would follow it. And based on my graph, I'll be almost at 3.5 days, right? A little under 3.5 days, I would have $10. Okay, that's how you would use your graph. You're doing the inverse of it. Okay, so the goal is to understand that the inverse of an exponential is what? Log, right? To undo the exponential, we have to use log. Okay, so it says, how would you set up? How would we set it up every single time? So if we're setting it up, then we're following the same rule every single time. Like we did our whole problems, we already set them up. So reference back to problems. We overshot it. We did all of our setups. How do we change our exponentials into a log? We have logs of the same base of our exponentials, right? The logs of the same base. Logs of the same base. So now, what if you wanted to know D? D equals 2 to the x. So no matter what the value is, what would I do? I would do what? Log what? Log base 2, but instead of having a value, what is it? D. No matter what it is, and that's going to help me find my x. Does that make sense? So every single time for this problem, if I ask for 300,000, could you go find 300,000? Yeah, you're just going to plug it in, right? If I ask for 400,000, but if I ask for time, we would go back to our original equation. Does that make sense? So if I said after 3 years, how much money would you have with a coin? One, what would you have to do to those years? Turn it into days, which would be a lot, which is why we're not going to type that in there, by the way, guys. It's going to be too much. But you get what I'm saying? All right. Hopefully we do, and we're okay with it. All right. So on your assignment for the week, remember this is your assignment for the week. It is due Thursday. So at the top of your paper, right?